Hello guys, welcome back. Uh, Yesterday we look into the Docker, right? Docker file and all, and we build the Docker into phases. One was build phase, and the second was the running phase, right? And we containerized one service and wiring it to the database also, right? Like it took us three command lines, right, and flags, and one a special DNS name. Let me show you. I think if I can show in the README file that, right, you can see, right. So build one command, second command this is two commands, right, and these are flags to reading env files and adding host, and this is the DNS for us, right. Now just to do wire, like containerize one service and wire the database to it, we need three commands, right. Now imagine how many commands we need in our real systems, like when we connect APIs and databases, UI, right? Like ML flows, Prometheus, Grafana, Loki, right? These things. By day of 24, we will run 8 plus services, right? All are hand typed, right, and we will have all hand typed Docker run commands with flags. That's not just engineering, it's incantation. Okay, if you don't know what incantation is, let me tell you. uh, Incantation means like special words that have a magic effect when spoken, right? Sung or chanted, the act of speaking, like singing and chanting these words. Okay, so for all of these like multiple commands, we need to remember those, right? So we can't keep up with all these commands, right? So for that, uh, I am just activating the uh, virtual environment. Okay. So for the solution for this is for us is the Docker Compose. Okay. So Docker Compose is the fix for us. One, we will have one YML file. It will declare the entire stack for us. Okay. YAML is yet another markup language. This is for Y, right? Yet another markup language. This is and markup language. Okay. So this is all for Y here, and this AML is used like this. Okay. Docker Compose is the fix here. It will declare the entire stack. Okay, every service we have, how they connect, what data survives, right? And one command will bring it all to life, which is Docker Compose. This will be the command, very important command for us. And here is a deeper thing for you. The actual lesson of today, like this will be your first taste of this declarative infrastructure. Okay, this will be a first aid for like what is this declarative infrastructure? It is like you describe what you want, right? What you want, then the tool will figure out how to do that. Okay. So hold this word declarative infrastructure with you for a moment, and you will need it for very long time. Okay. Like declarative Terraform, declarative Kubernetes, declarative devops, and it's all declarative infrastructure taken to its logic extreme in all these, right? So today's title, YML file is the gateway drug to the entire modern infrastructure world. Okay. So job relevance of this topic for you is so Compose is on every run our stack locally. README at every company you will ever join. So it is the local dev standard here. By end of stream, the 4-terminal circus is dead. Okay, and replaced by one file and one command only. Command to git. So anyone doing cloning the repo runs the entire platform in just one line. Okay. So we will need some concepts to go ahead from here, right? If I try to change the color of the paper color to this color, right? It will be also nice. Then I am choosing this as first topic for you guys is imperative versus declarative, right? So it's just a philosophical shift for us, right? So there are two ways to get a coffee. Okay, One is imperative, like you walk to the machine and insert a pod, place a cup, and press the button there, and just wait for 40 seconds, right? After that, you add milk. So these are step-by-step commands, right? And if you are interrupted in halfway, the state is a mystery, right? And second thing is declarative. You say, okay, I want a flat white on my desk. Just you describe end state. The barista will figure out the steps, right? And if one exists already, they do nothing. So yesterday was imperative for us, right? Like Docker run dash p dash e add host. All this command, right? Like Docker run here dash p dash env file, then add host, right? A spell to recite in order also, right? Every time we have to do that in order. Today we write a declaration. So what will be our declaration today? Like my system consists of these three services, okay, connected like so. With this data persisted, right? The tool reconciles reality to match the declaration and it will run it twice, right? And nothing to do with it. Reality already matches, right? Change one line, only what difference is applied. Okay. So you understand this imperative versus declarative here, right? So the word itself, what this word imperative means, right? This word imperative means tell the computer every step to perform, right? Tell the computer every step to perform, right? This is imperative. Like giving directions, like you walk 10 meters, then turn left, walk 5 meters, open the door, sit down, right? These are the every step you are trying to say. Like you tell how to do it, right? And so yesterday our this Docker run is also imperative, right? You said Docker run, then P export the port or open the port, right? Then E here, like it's not here, but like uh, this is it there, right? Instead of E, I used this, right? These are the flags. Then add host, right? Image name after that. This is the image name and the version, everything, right? So you are telling Docker exactly how to start the application, right? This is imperative. Problem with imperative is, suppose you forget this, like this. Suppose you forget this. right? Okay, I should not tell you in this file because it can you may get corrupted. Where should I keep this? Okay, it's in mode now, right? So as you can see here, right? Let's say you forgot this. Now browser cannot connect, or suppose you forget like this here, then environment variables fails to connect, right? Another problem, suppose halfway through someone interrupts you, like you don't know what state the system is in. Like your step one is this step ran, then interrupted, right? Is Docker running? Like you don't know like if it is Docker running or not. Is Postgres is running or not? Like till when commands are running or not, right? Nobody knows. So this is what the instructor like I'm trying to say to you. The state is mystery in that case if you are interrupted in between, right? Second method for doing things is declarative method, right? Like declarative, like don't tell computer how, okay? Tell it what you want, right? So instead of saying like okay, you walk this meter, then turn left or right, then press this, then wait, then pour the coffee like this, right? You simply say okay, I want one flat white coffee. You describe the final result. Someone else will figure out for you the steps, okay? Let's take a coffee shop example. You tell a barista like okay, one flat white please, right? You don't care whether they grind beans, stream milk, right? Pour coffee or use another machine. Right? You only care about the final result. So the thing is here. Right? Docker compose, okay? This thing is declarative, okay? Docker compose is a command which is declarative. Instead of writing docker run, right, every time you write one file, right? So example, instead of writing docker run every time, you write one file only, okay? So for example, you have this file called services, then you have APIs, then you have also Postgres as a service, right? And also you have services like this UI, right? You have all these services, right? Now you are telling Docker like my system should contain 3 services, right? Not how to start them, right? You just tell service these 3 services must be there, right? You are not telling how to start those services, right? So Docker compose will read the file, okay? Like so there will be a file, okay? Docker compose.yaml, right? So flow will be like you have this file, then you run a command called docker compose, right? It will create containers, right? After that it will create the network, what you like porting and all, right? Create the volumes, then it will run everything, right? So you describe the desired system, right? Then Docker will figure out the commands. What is your desired state? desired state is, this is very important phrase. Okay, suppose you want three containers, right? Suppose you want three containers, right? Right? Suppose you want three containers. Uh, like API, it's running, right? Then also you want a database as a container, running state, right? And also you want a UI container, it's also running, right? So you want this is your desired state, right? Right? This is your desired state. And reality is, suppose the API only thing running is your API, right? Like reality is this. This is running and this is not running. Let's say, okay. So your reality is not matching your desired state, right? So it will go in the reconciliation state. Okay. Right. Now Docker Compose will say I need to make a reality match the declaration. Okay. So it will start database and UI, right? So it will start database and UI also, right? So this process is called reconciliation, right? Reconciliation. And this, why this is very important, right? Why it is important? Suppose everything is already running, like your database is running, your API is healthy, right? And your the what was the last thing? UI is running, right? And if you type this thing, if you type Docker Compose up, if you run this command again, right? So Docker will compare the desired state and reality state. So they are already equal, right? So nothing changes in this, right? This is called the idempotence. If all are already running, then reality equal to desired state, right? Then it is called, it all is called, let me say it like this, orange, idempotent state, right? Nothing changes, right? In this case, so running the same command multiple times gives the same final state, right? So Compose compares the difference only, right? Okay, so that was the concept today. Then we have this next thing, okay? Okay, so guys, next concept for is in this is let me tell you is services. Services, okay, like services are containers with rules, okay. So yesterday what we learned is container is one isolated box, right. So now today we will learn a container, okay. A service is a container with a specific job in the system, right. So let's we will build the intuition step by step for this concept. So first, what is a service, right? Before Docker Compose, you thought like this: container 1, container 2, container 3. Just 3 containers are there, just like that, right? So now Docker Compose is changing your thinking, right? Docker Compose changing your thinking like this. One is one is UI service, right? And then you have API service in Docker Compose, right? You want these services, right? And you have database service. So this Docker Compose changing your thinking, right? Like declarative thinking it is, right? So each container will have a purpose now, okay? So this is why the container, or we can say the compose, calls them services, okay. So when a container have a purpose, or we can say role, then it's a service, right. So what does it mean by container with rules, right? So let's say, imagine a company, right? A company has people, a company has CEO, it have engineers, right? They have accountant. So these all are people, right? But each has a different role. Similarly, Docker has containers, okay? Docker has containers, but each container will have one specific job. So it's a very important idea, right? Let me write it here. There is a container, gave it a job, right? Now it is called a service, alright. So in our application, our project has these 3 services, like we have UI, we have API, we have database service, right? So let's understand each one. Service 1 we have, okay. Service 1, UI, right? So this is our Streamlit application, right? So what is this service job is, right? Its job is show the web page, take user input, right? And send requests to API and display the result. This is just job, right? Job is for of this service, like show web page, right? And take in that web page, take user input, and after that send request to API, right? Then display the result. This is our service. So you notice one thing here. It does not running ML. It does not talk directly to Postgres SQL, right? It only talks to API. Okay. Now we have service 2. Let me change the color. Right. We have service 2 also, which is API. What is API job? This is our fast API app, right? So this is our brain, right? Yep. Its job for this is what it will do. It will receive request, right? And through the post method actually, and then it will load ML models, right? Then it will predict things, okay? And then after that store the history and return answer. Now you notice something here. It's not it just only API talks to database, right? API talks to database. Now we have a service 3 also. Here we have service 3, which is DB, right? Database Postgres SQL app, right? Now its only job is to store data. For example, like when this prediction history calls this, right? It does not know anything about Streamlit or machine learning models, right? So full flow would be like this. You have user goes to UI calls request API to database, right? So every service here has its own responsibility. This is called separation of concerns, right? So let's understand the full picture also, right? UI make a HTTP through HTTP request. It make a API request to API, right? Then through API through SQL it store data to database. Let's explain every row here, right? This UI to API, right? So arrow says like HTTP, right? Meaning UI sends a HTTP requests like you can say post / predict, right? For example. So exactly like our curl command, right? And here it is using SQL like select asterisk like this, because database don't understand HTTP, it understands SQL, right? Also it will like declare many things like ports, right? So UI is port 8501, right? What does it mean? It means like Streamlit listens on 8501, right? Then you have API port also, which is 8000, right? Like fast API listens on port 8000, right? And this database also you have some port database 5432, like it will say post GraysQL listens on 5432, right? So mathematically we can say, like every service has its own port, right? Every service has a port, right? Example, you have everything has, right? No two services should use same port, okay? No two services should same port, okay, inside the same network. Inside same network, right? Also, these all services, okay, will have one shared network. It's very important concept. Let me go for custom color, which is this. Very good color. Right, it's good. So one concept is one shared network. Okay, what do I mean by it? Yesterday we manually used this, right? Like host dot docker dot internal, right? Because containers didn't know how to find each other. So what Compose do? Compose automatically creates a private network, okay? Like, so this will be like this. Compose network. It will look like this. It will have UI, API, and DB, right? So every service will join this network. Now UI will not need localhost or IP addresses, right? It simply says API. Because Compose automatically creates DNS, okay? For example, instead of doing this 172.17.0.4, you write just API. You just write API, right? So Docker will translate it API to 172.x.x.x, okay? Anything automatically. Same for database. Instead of localhost, you write DB, just DB, okay? So we don't need now, because we already created a virtual private network with this Compose network, right? So no IP address needed now, because its own DNS service is here, okay? Mapping, no host, Docker, internal, everything we don't need now. And one persistent volume. Next concept is this one persistent volume. Okay. What do I, so it's a very another very important concept. Remember that containers are temporary, right? Suppose database container dies, so without volume, right, without volume, if container is dies, right, so container deleted, then all data is lost. This is very bad, right? So what compose do, let me this compose creates uh, PG data, right? It's a volume. Okay, think of volume as an external hard disk. That's okay. So think of it like this. Database container we have, right? It will create a volume which will be a hard disk. Okay. Now suppose container crashes, right, or deleted, but this container crashes, but this volume and hard disk will remain, right? So we can, what we can do, we can create new container, right, and attach the same value with this container, right? If it is in the case of deleted, right? So that data will return. So mathematically it is like without volume, deleted container will be deleted data, right? With volume, deleted container is just container will disappear in that case, but volume it will still exist. Okay, therefore data will survive. And volume is independent of container. Okay. So we have three services. So notice here, Compose is not running one program. Okay, it is running three independent containers. Okay, one is UI, API, and database, right? So one command will create all of them. Okay, so this diagram is today's YAML for us, and okay. All right, let's continue. All right. So next concept, guys, is let me. It is uh, container networking. Okay, this is our new concept. You can say it is DNS by service name. Okay, so here this is one of the biggest advantage of Docker Compose. So it will solve the networking problem we were struggling yesterday. Okay, so we will build the intuition from yesterday's problem only. So remember this command yesterday? It was docker run. Then we had this env file dot env, right? Then we have this let's say here add host is equal to host dot docker dot internal, and we have this host gateway. Then we had the image and all, right? So you needed this, right? Yesterday you needed this because our architecture looked like this, like you had Ubuntu host, right? And you had PostgreSQL on localhost 5432, right? It was listening on this port, and you have Docker container, right? You have this you had Docker container for fast API, right? Now container wanted to reach PostgreSQL, right? But local host, like if you want to reach here, and you say okay, local host 5432, right? If you say like this, but this local host means container itself, right? So not your Ubuntu machine, right? Not your Ubuntu machine. So you needed host.docker.internal as a bridge. Okay. So the compose will make the whole problem evaporate now. Compose completely removes this headache. How? So what it will do? Uh, Compose will create one private network. Okay, let me write it. It's very important. Compose will create one private network. Okay. So you can imagine it like a Docker is building a private room, which has like UI, API, and DB. Every service automatically joins this network, right? So every service automatically joins this network. Okay. So how this compose network looks like? It looks like this. Compose network, right? You have UI, API, and DB inside it. Okay. Here. Okay. Yesterday we had this transition, right? Yesterday we had this host. You had a container, right? It goes to host machine. Then after that it will connect to database, right? But today everything will lives inside Docker. Okay. So Docker network is like this. UI it is, API, DB, everything. No need to leave the Docker, right? So every service gets a name, right? Suppose this YML, your YML says like services UI, API, and DB, right? Every service gets a name, right? So Docker will, let's say this is your YAML, right? Right. Now Docker will automatically create three names like UI, API, and DB. These three becomes the network host name, right? These becomes no, it was a very good idea. These become network host names. Alright, this is the magic. Like suppose API wants database instead of writing any uh, like this uh, like this 172.17.0.1 or 5 like let's say, or like localhost or host.docker.internal, right? It simply writes db. It writes just db, right? Because it is named database service is named db, right? So the old way of doing things was like this, like you had a database URL, right? Base URL is equal to like this Postgres and everything, like, and you have this host dot docker dot internal, then you have 5432. But this is old way of doing things, right? Now what you do in database URL, you write this Postgres and everything you need at database like DB 5432, right? It is much simpler now, right? Let me show you what I mean. In environment file, this was like Postgres, radar, this the user, then username here, and this is a password, and then you need this. Instead of this, you just need write DB, right? Because it's the name of this. Okay, and yeah. Why this works because Compose runs its own DNS server, right? What is DNS? Domain name system. DNS. Compose runs its own DNS, domain name system. Okay, normally DNS translates Google like this, like google.com, like 142.250.x.x, like right. Your computer doesn't know Google's IP, right? DNS tells it. So Compose does the same thing, but only inside Docker network, right? So the flow could be like this, right? Like, okay, API ask, right? Where is DB? Compose DNS will tell DB. DB is mapped to like this port 0.4 like this, right? The translator, Docker does the translation automatically, right? Why is this better? Imagine database restarts, right? Old IP was like something else, now new IP is something else. So if you broadcast the IP, everything breaks, right? So Compose DNS automatically updates the DB, right? Always correct IP will be there, right? And why we are not using localhost? Yesterday localhost was container itself, which was wrong. Today DB is the database container, which is correct, right? Why not in IP? IP is changed because names don't, right? Imagine moving my house phone number change, like, okay. Why we are not using this host.docker.internal, right? Because the database is no longer on the host. Okay, it is inside Docker. So architecture is like yesterday. Architecture was this: host, PostgreSQL, right? Today, it's an old way of doing things. Today we do Compose. We have database container. So we don't need this, right? No bridge needed. So database URL we can we can uh, remove this and use db2d, right? So you notice only host name and changing on the database, everything else is still the same, right? And also this is very security concern also here, right? Because yesterday you were running like we were running like this 8000.8000 and like this 5432.5432, right? Here, let me show you. Like here also and in this 8000, right? So database was visible from our laptop, right? Now anyone who can reach your laptop can try connecting to it with Compose. With Compose, database stays inside the private network and database never opens a door to the outside, right? Only UI and API expose the ports. So we database can only be reached by API, right? So we now the attack surface is smaller. Number of ways an attacker can reach your system, right, is like less now. And next concept, guys, is very important for us, which is volumes. The data problem. Okay. So this is also one of the most important concept in Docker. If you understand volumes, you understand why databases are treated differently from APIs. Okay. So let's build the intuition from the beginning for this also. Okay. Just a minute. So the problem is, suppose you have a Postgres SQL running, right? Let's say in a Docker container. Right. So just a minute. Right. Okay. Let's continue. Suppose you have Postgres SQL running in a Docker container, right? You have this Docker container, and in this container you are running PostgreSQL, You have tables in this, you have rows, and you have data, right? Everything looks fine here, right? Now, if you run this docker rm container id, okay, or like this docker run rm . So in this case, container will disappear. So your question will be, okay, what happens to my data, right? So by default, the answer is everything inside a container will disappear. Okay, everything inside a container will also disappear. If you delete this container, all things go, right? So this is exactly what the these commands gonna do without volume, right? Why? Because a container has its own file system. You know that, right? Think of it, file system as a hard disk, right? Like this container file system is like /app /user /etc /variable library PostgreSQL. This file system belongs to only to that container. Okay. So when the container dies, its file system dies too. Right? So at first this will sound terrible, right? Our data is losing, right? But for many applications it is actually perfect also. So why it's good, right? So for example, your fast API application, fast API application, right? It contains like fast API models, code, right? Suppose the container crashes, you simply start another one, right? So nothing important was stored inside, so everything behaves exactly the same, right? This is called the stateless. So this is your container, which contains fast API model and code. And if you this container is right, so if it crashes, then everything will be lost, right? Everything will be lost. Then you simply start another container, right? Because nothing important was stored inside, everything behaves exactly the same. Like fast API code will be same, models will be same, everything will be same, right? This is called stateless. Okay. So stateless is that our API keeps nothing local. Exactly. Your API stores nothing important inside its own file system, right? Like, what is the API? What do API do? API receive request, then predict, then response, right? If it if it dies, old API deleted, new API works again, right? So nothing is lost. But database is different, right? Postgres SQL contains users, prediction history, tables, records, right? Now imagine in database you have predictions table, right? You have this table, okay, and you have 1,000 rows are stored, right? And if you delete the container, so without a volume, these 1,000 rows are deleted forever. This is a disaster. So to fix this, we need volumes. Well, what is volume? It is just storage outside the container, okay? So instead of storing data inside the container, the PostgreSQL will store data inside the volume. If you delete the container, volume will remain, okay? And one thing is, Docker manages it. Docker manages it. Like Docker manages outside the container life cycle. Okay, life cycle means like you create, you run, you stop, you delete. Okay, so containers have this life cycle, right? Volumes do not, okay? So if you create and delete a container, but volume still exists. So volumes live independently, okay? One more thing is, these are plugged into the container. Okay. Plugged into the container, or more, these are plugged into container as a path. So suppose PostgreSQL store data in this, where let's say PostgreSQL data, right? So what Docker do? Docker will mount a volume here or there, we can say there, right? So this is a container. It's writing this on here, this location, right? PostgreSQL data, and it will Docker will mount the volume here. Okay. Now PostgreSQL thinks like it's writing to a normal folder. It has no idea it is actually writing to a Docker volume. Okay. So next important thing is stateless and stateful, right? So stateless means here no important data, local data. Okay. Important local data. Example, our Streamlit API key, right? Request, response, and nothing is stored there, right? Stateful means keeps important data. Right? Like tables and PostgreSQL. So API is stateless because no important files created there, nothing permanent, right? And database is stateful because history changes tomorrow and you want that history, so the data must survive, right? So for scalability, stateless services can later scale to n copies, right? Suppose 1,000 users arrive instead of one API, right? Docker or Kubernetes creates API 1, API 2, API 3 like this, all identical because they keep no state. So mathematically, if one API handles 100 requests per second, then 4 API handles approximately 400 requests per second. Scaling is easy. So database cannot scale like this, right? Suppose you create 3 PostgreSQL containers, DB1, DB2, DB3, right? Each has different data. Now which one is correct? Impossible, right? The database needs careful synchronization. This is why stateful applications are harder. So we will study this also. Kubernetes has different machinery, right? So Kubernetes has special objects like stateful sets for databases. We will study it later, right?